Ever wonder if you could build an AI application?
Hmm.
Or what about those AI hallucinations everyone keeps talking about?
Right.
Well, we're going to tackle all that and more in this deep dive
Okay.
into AI engineering,
Sounded good.
all based on Chip Huyen's book.
Oh, okay.
Same name, AI engineering.
Yeah.
Get ready to go from AI newbie to sounded like you've been coding this stuff for years.
I think what I find so fascinating is how
Yeah.
Queen makes this super complex field feel approachable.
Yeah, for sure.
He doesn't assume you're an expert already,
Right.
which is so refreshing.
For sure. Okay, so first up, he dives into these things called foundation models,
Mm-hmm.
which are like the building blocks of modern AI.
Yeah.
It explains how these, large language models or LLMs
Right.
and their multimodal cousins, LMMs,
Oh, wow.
are kind of changing the game.
Yeah.
Like, remember when AI could barely write a simple email?
I know.
Now we've got models like GPT-4V and Claude 3 that can understand images, A&D text.
It's wild.
It's mind-blowing.
Yeah, and what's interesting is that Yoon really emphasizes how important it is to really understand these foundation models
Yeah.
before you can even think about diving into like the specific techniques. Kind of like building a house.
Yeah.
You need that solid foundation before you can start
Right. Yeah.
putting up the walls, adding a roof.
Totally. So once we've got that foundation, where do we go?
Yeah.
Well, Huyen lays out this thing called the AI engineering stack,
Okay.
which sounds very intimidating,
Yeah.
but he breaks it down into like 3 manageable layers.
Right. And he starts with application development, which is kind of where most people will like start their AI journey.
Right.
Then there's model development, and then
Okay.
finally infrastructure.
So you don't need to be a coding wizard to get started
Ooh, no.
with AI.
Yeah, you can focus on building the application first.
Right.
And then delve deeper into the technical layers, as you need to.
Okay, that's reassuring. So let's say I'm starting with application development. What are the key things I need to know?
So he stresses 3 core components: evaluation,
Okay.
prompt engineering, and building the AI interface.
Got it.
So evaluation is crucial because it helps you measure how well your AI is actually performing,
Right.
and identify areas where you can improve.
Okay.
Prompt engineering is all about crafting effective inputs for your model,
Okay.
like giving it clear instructions, making sure you get the results you want.
Right.
And the AI interface,
Yeah.
that's how users will actually interact with your application.
Right.
And making that user-friendly is key to its success.
Okay, I'm starting to get the picture.
Yeah.
Before we dive deeper into, those components, let's talk about model development for a sec.
Okay, yeah.
Huyen seems to be pretty adamant about the importance of training data.
Right.
You can't expect an AI to be a genius if you feed it garbage.
Exactly. He really emphasizes that a model is only as good as the data it's trained on.
For sure.
Uses this analogy of teaching a child.
Okay.
If you only expose them to a limited set of information, they're not going to have a full understanding of the world.
So what should we be looking for in training data?
Well, he points to 3 key factors: quality, coverage, and quantity.
Got it.
Quality means ensuring the data is accurate, consistent, and relevant to the task at hand.
Yeah.
Coverage is about making sure the data represents the full spectrum of what the AI needs to understand.
Got it.
And quantity, of course, refers to having enough data to train the model effectively.
Quantity over quality, I always say.
Well, not exactly.
Okay.
He actually argues that a small amount of high-quality data can often outperform a massive data set of low-quality data.
Oh, interesting.
It's like having a few close friends who are truly supportive versus a huge group of acquaintances who aren't really there for you.
Right. I see. Okay.
Yeah.
That's a great point. So let's say we've got our training data sorted out. Huyen then throws a bit of a curveball, talks about this thing called data contamination.
Oh, yeah.
What's that all about?
Data contamination is basically when your training data overlaps with your testing data.
Oh.
So imagine you're starting for a test using the actual test questions. Yeah. You're going to get a great score, but it's not going to accurately reflect your understanding of the material.
Right. Okay.
Same principle applies to AI.
Yeah, okay.
If your model's already seen the data it's being tested on, the results are going to be artificially inflated.
So sneaky.
Yeah.
So how do we avoid this data contamination disaster?
He gives some strategies for preventing data contamination. It involves carefully separating your data into distinct training and testing sets. And making sure there's no overlap between them.
Gotcha.
He also emphasizes the importance of using diverse data sets to avoid biases and ensure that your model can generalize to new situations.
Okay, so we've got our data prepped, contamination-free. Now comes the really crucial part, according to Huiyan evaluation. Why is it such a big deal?
You know what's interesting is that evaluating AI models, especially these, open-ended foundation models, is like a whole different ball game compared to evaluating like traditional machine learning models. With traditional models, it's often like a clear-cut right or wrong answer. But with foundation models, it's more nuanced. You're dealing with language, context, user intent, which can be much harder to like quantify.
He makes it sound like evaluating these foundation models like kind of an art form.
It definitely has its complexities. He spends like 2 whole chapters delving into different evaluation methods, each with its own strengths and weaknesses. Talks about metrics like perplexity, which measures how well a model predicts the next word in a sequence. And CLIP score, which assesses how well a model's output aligns with an image. He even discusses using AI judges, which are basically AI models trained to evaluate the output of other AI models.
Wait, so AI judging other AI?
I know, it's kind of like...
That's AI inception or something.
Yeah, it is.
That's fascinating, but I can see how it could get pretty complicated.
Yeah, it definitely adds another layer of complexity. But it really shows how quickly the field of AI evaluation is evolving.
So there's no like one-size-fits-all solution?
Not at all. You really need to choose the right evaluation method based on like your specific application and the type of model you're working with.
So we've got our foundation models, we've navigated the treacherous waters of data contamination, and we're armed with like a toolkit of evaluation methods.
All right.
What's next on our AI engineering adventure?
Well, once you have a model that you're confident in, the next step is figuring out how to actually use it effectively. And that's where prompt engineering comes in.
Okay, let's talk about talking to AI.
Yes.
Prompt engineering. It sounds so technical.
I know, but...
But I'm guessing it's like more about communication than code, right?
Exactly. Huiyan describes prompt engineering as the art of crafting effective inputs for foundation models.
So it's about like speaking the language of AI.
Yeah, getting it to do what you want.
Okay, so giving clear and concise instructions to our AI overlords.
Well, overlords might be a bit dramatic. But yeah, the idea is to provide the model with enough context and guidance to generate the output you want. It's about understanding the model's strengths, limitations, and using language to unlock its potential.
I'm intrigued.
Yeah.
What are some of the key principles of like effective prompt engineering?
So Huiyan dives into several key factors, including context length, prompt structure, and even the specific wording you use. For example, he highlights how the model's context length, essentially like the amount of information it can process at once, can significantly impact its performance. He even cites the example of Gemini, a new model with a whopping 2 million token context length.
2 million?
Yeah, I know.
That's like feeding it an entire library.
It's huge, which means it can handle a massive amount of information in a single prompt.
But I imagine there's a balance to strike.
Oh, for sure.
Like too much information could overwhelm the model.
It's not just about cramming in as much information as possible. It's about strategically structuring your prompts to optimize the model's understanding. He introduces this concept of prompt decomposition, where you break down complex tasks into smaller, more manageable chunks for the model to process.
So it's kind of like breaking down a big project into like smaller, more digestible tasks.
Exactly. And he even talks about prompt chaining, where you link these smaller prompts together to guide the model through a more complex workflow.
It's like we're building our own AI assembly line.
Yeah, kind of.
But what if our model, even with all this clever prompting, still needs access to information beyond its initial training data? I'm guessing that's where this thing called RAG comes into play.
You got it. RAG, or Retrieval-Augmented Generation, is all about connecting your model to external data sources. Essentially giving it access to like a much broader knowledge base.
That sounds incredibly powerful.
Yeah, it is.
But how does it actually work? Like, how do we make sure the model is finding the right information from this vast sea of data?
So Huyen breaks down the mechanics of ARA, explaining how it relies on retrieval algorithms to find the most relevant information from these external sources. He discusses two main approaches. Term-based retrieval, which is like searching for keywords, and embedding-based retrieval, which relies on mapping words and concepts to a vector space.
Vector space.
Yeah, it sounds
like we're diving into some serious math here.
Yeah, it does get a bit technical, but the key takeaway is that each retrieval approach has its own strengths and weaknesses. Term-based retrieval is good for finding specific keywords, but it can miss out on nuanced relationships between concepts. Embedding-based retrieval can capture those relationships, but it requires more sophisticated techniques for comparing and ranking results.
Yeah, this is where my head starts to spin a little bit.
I know.
But I'm starting to see how RAG can take our AI applications to a whole new level.
Yeah, totally.
It's like giving them access to the collective knowledge of humanity.
Exactly. And to manage all this external data, Huyen introduces the concept of vector databases, which are specifically designed to store and query these vector representations of information.
Vector databases, it sounds like something out of Star Trek.
It does, but...
Seriously. I can see how they would be essential for handling
for sure.
the massive amounts of data involved in RAG.
Absolutely. They're becoming a crucial part of the AI infrastructure. Especially as we move towards more complex and data-intensive applications.
We've covered so much ground already, and it feels like we're just getting started.
Yeah, for sure.
I'm eager to learn more about how we can actually put these techniques into practice and build real-world AI applications.
Yeah.
We'll dive into that and more in part 2
of
our deep dive into AI engineering.
Sounds good.
Stay tuned.
All right. So, picking up where we left off, let's delve deeper into a crucial aspect of building AI systems data.
Right.
It's more than just gathering, a massive amount of it.
Yeah, it's like having all the ingredients in the world doesn't make you a master chef.
Exactly.
You got to know how to use them effectively.
Precisely.
Yeah.
And Huyen stresses we need quality, coverage, and quantity.
Got it.
A trifecta for data excellence.
Okay, quality makes sense. Garbage in, garbage out, as they say.
Right.
But what does he mean by coverage?
So think of it like training an AI to understand music. If you only play classical music, it's not going to have a clue about jazz or rock.
Right.
Coverage is about ensuring that your data represents the full spectrum of what your AI needs to understand.
So breadth and diversity.
Exactly.
Ought to expose our AI to a wide range of examples.
Huyen illustrates this with the development of Llama 2. They specifically included data from diverse domains like science, history, even coding. To create a more well-rounded model.
That makes sense. But what if we need data that's difficult or even impossible to find in the real world, say for a super niche topic or something sensitive?
That's where synthetic data comes in. Huyen dedicates a good chunk of the book to this, highlighting how it's becoming a game changer for AI engineers.
Synthetic data, is that artificial data?
Exactly. It's about creating artificial data that mimics real data. So, for example, if you're building a self-driving car system, you can't just let it loose on real roads to learn. Way too risky. So you create these simulated environments with synthetic data to train it safely.
So creating a virtual playground for our AI to learn and experiment in without real-world consequences.
Precisely. And he even talks about using AI itself to generate synthetic data.
Whoa, so AI.
It's AI creating training data for another AI.
That's kind of trippy.
It is.
But I can see the potential. We're breaking down these barriers of data acquisition. And giving AI engineers the power to create the data they need. regardless of real-world limitations.
Powerful tool.
Yeah.
But Huyen reminds us to be mindful of potential biases that might creep in during synthetic data creation. Wow. It's all about striking that balance between artificiality and representing the real world accurately.
Right. Yeah. We don't want to create an AI that's biased or detached from reality.
Right.
Now, once we have a well-trained model, how do we make sure it can actually be used in the real world? I mean, these models can be huge, computationally demanding.
They can be. That's where inference optimization comes in.
Okay.
It's about making your AI model work smarter, not harder.
It's like fine-tuning a race car.
Exactly.
To get the best performance without burning through all the fuel.
Precisely. Huyen dives into a whole range of techniques, from optimizing the model itself to leveraging specialized hardware.
Right.
He talks about quantization, where you reduce the precision of the model's numerical representations to make it smaller and faster.
So compressing a file without losing too much quality.
That's a good analogy. He also discusses techniques like distillation, where you train a smaller, more efficient model to mimic the behavior of a larger model.
So it's like creating a mini-me version of your AI that can still do the job with fewer resources.
Exactly. And on the hardware side, he talks about specialized chips designed specifically for AI inference.
That's like having a custom built engine for your AI race car, optimized for speed and efficiency.
Exactly. And Huyen makes it clear that choosing the right optimization techniques really depends on your specific application and resource constraints.
Gotcha.
It's about finding the right balance between performance and cost.
Okay, so we've got our model running smoothly,
right?
But how do we make sure it plays nice in the real world?
Yeah.
Especially when it comes to things like safety and reliability.
That's where Chapter 10 shines.
Okay.
Building and monitoring AI applications for real-world use.
So it's like taking our AI out of the lab and into the wild.
Yeah, but responsibly.
Responsibly, yeah. So it's not enough to just build a cool AI.
No.
We need to make sure it's safe and reliable when interacting with real people and systems.
Exactly. Huyen emphasizes the importance of guardrails.
Okay.
Both on the input and output sides.
Guardrails, to keep it from going off the rail.
Exactly. Input guardrails prevent users from entering data that could cause the AI to, misbehave.
Okay.
For example, if you're building a chat bot for a bank, you'd want an input guardrail that prevents users from entering, their social security number.
Makes sense, yeah. What about output guardrails?
Those are designed to filter the AI's responses to prevent harmful or inappropriate outputs. For example, you might have an output guardrail that prevents the AI from generating offensive language.
So it's like teaching our AI good manners, making sure it doesn't accidentally say something that could offend or harm someone.
Exactly. And beyond guardrails, Huyen stresses the importance of building comprehensive monitoring systems.
So we're talking about keeping a close eye on our AI to make sure it's behaving as expected.
Precisely, yeah. These systems track all sorts of metrics, like the AI's accuracy, response time, even the types of requests it's receiving.
Okay.
If something looks fishy, the system can alert human engineers to investigate.
It's like having an AI watchdog that's
Exactly.
constantly on the lookout for potential problems.
And even with all these precautions, Huyen emphasizes the importance of user feedback. It's not just about catching errors. It's about understanding how people are actually using your AI and identifying areas for improvement.
So like a continuous feedback loop.
Exactly.
Where our AI learns and evolves based on real-world interactions.
Exactly. It's a reminder that building and deploying AI is an iterative process.
For sure.
We learn, we adapt, and we constantly strive to make our AI more useful, reliable, and align with human values.
This has been a whirlwind tour.
I know.
Some pretty complex concepts.
A lot to cover.
Yeah, we've covered everything from synthetic data to guardrails and monitoring systems. What are some of the key things listeners should take away from this part of our deep dive?
I think the biggest takeaway is that building AI systems is more than just writing code.
Right.
It's about understanding data, thinking critically about potential biases, and building systems that are robust, reliable, and safe to use in the real world.
Yeah.
It's a fascinating and rapidly evolving field.
Yeah.
And Nguyen's book provides
valuable roadmap for anyone who wants to understand and contribute to the responsible development of AI.
Well said. And in part 3, we'll wrap up our deep dive with some final insights and takeaways.
Sounds good.
From Nguyen's book.
Okay.
Stay tuned.
Welcome back to our deep dive into AI engineering. We've covered so much.
I know, it's a lot.
From foundation models to data shenanigans.
Yeah.
And even how to keep our AI from going rogue in the real world.
It's a lot to think about.
It is, yeah. Now let's try to distill all this knowledge into some key takeaways. What are some of the things that really stood out to you from Nguyen's book?
You know, what really struck me was how Nguyen emphasizes the importance of making informed decisions throughout the AI engineering process. He doesn't just present a laundry list of techniques.
Right.
He helps you really understand the trade-offs involved and when to actually apply each one.
Right. Remember when we talked about RAG versus fine-tune?
Yeah.
It felt like such a
big decision.
Crucial decision point.
Yeah.
Do I give my model access to more information?
Right.
Or do I train it to be more specialized?
And humans' guidance on that was so helpful.
It was.
He basically says, it boils down to the type of failure you're facing.
Okay.
If your model is struggling because it doesn't have access to, the right information, then RAG is your go-to solution.
Okay.
But if it's more about, refining the model's behavior or getting it to perform a specific task more effectively, then fine-tuning is the way to go.
Yeah, it's like he's giving us a mental framework.
Totally.
For diagnosing problems, choosing the right approach.
Instead of just throwing techniques at the wall and seeing what sticks, we can be more strategic and intentional.
Right. Okay, I like that. And then another key takeaway for me was the emphasis on evaluation.
Yes, throughout the entire process.
Yeah, it's not just a final step.
No, it's ongoing.
It's something you're constantly doing.
Exactly.
To guide your development, make sure you're on the right track.
Checking your compass regularly.
Exactly. And it's not just about measuring accuracy either.
No.
Nguyen talks about evaluating things like fairness, robustness, even the explainability of your model.
It's about making sure your AI is not only performing well, but also behaving responsibly and ethically.
Such an important point. It's easy to get caught up in the
technical stuff,
technical aspects of AI engineering.
Right.
But we can't forget about the human impact of these technologies.
Totally. And that brings me to another key takeaway.
Okay.
The importance of user feedback.
Right.
It's not just about getting compliments or complaints. Yeah. It's about treating user feedback as a valuable data source that can help us continually refine and improve our AI applications.
It's like having a constant stream of insights from the people who are actually using our AI.
They can tell us what's working, what's not working, and what they'd like to see in the future.
Exactly. And by incorporating that user feedback into our development process, we can make our AI more relevant, more user-friendly.
For sure.
And ultimately more successful.
This book has really opened my eyes to
me too.
The complexities and possibilities of AI engineering. Yeah. It's such a
dynamic field.
Dynamic and rapidly evolving field.
Yeah.
And Nguyen has done a brilliant job of capturing its essence and providing practical guidance.
Yeah, for sure.
For anyone who wants to
be a part of it.
Be a part of it.
So as we wrap up this deep dive, what's one thing our listeners should take away? What's the one nugget of wisdom they should carry with them on their AI journey?
I think the most important thing is to approach AI engineering with a sense of humility and a deep awareness of the potential impact that these technologies can have on the world.
Yeah.
It's a powerful field.
It is.
With immense possibilities, but it's up to us to ensure those possibilities are used for good.
Well said.
So keep learning, keep experimenting, and always remember to ask yourself, How can I use AI to make the world a better place?
Beautifully said. That's a perfect note to end on. Thanks for joining us on this deep dive into AI engineering. We hope you found it insightful and inspiring. And remember, the future of AI is in our hands. Let's build it wisely.